Perfect.
And we're off.
Great. It's going to be the first line of the transcription. We're off. So that'll make it nice and short when we put it to the AI. Only joking, only joking. Okay, folks, thank you very much for coming along today. I've been trying to catch up with the rewatching last week's meeting, looking at the Excel sheet, but as is tradition, I guess the request would be for Shin, if you could give us an update on the last meeting, how you think it went, and where we are.
Yeah. Yeah, I think I just checked the minutes. I realized it seems we didn't uh, make a one, but mostly of the meeting is still a discussion the platform and also the operating system support. So I after that meeting we submit a PR. I think Dominic submit the change if I remember correctly, and also Martin give some kind of update on that. So all the change actually we can trace from the SIG, the platform document. So maybe I can just type the link to that document here.
Perfect.
Yeah, and we talked about let me see. We talk about like add Zypher ESP-IDF things, and also adding x86 into the target. Yeah.
Okay.
Yeah.
And I think I saw a general agreement that in terms of how we should work is define a list of target platforms. So just for a recap for everybody, the eSig would like to get on and do some more innovative API-based work, but we agreed that we would first deliverable that we would produce would be an agreed target list or target platform list of real-time operating systems, hardware instruction sets, and form factors, because this would help everybody in the WASI community understand the hardware constraints we're trying to target and how we would like to try and achieve those goals. And it helps when we come down to some of the questions we had around making the component model work for these very small targets. And if there was a workaround, actually having the hardware specs would really help folks. And I know Luke's on the call and we had a really good discussion about that as we set up the eSig. So I think we've said this before, it feels a little bit restrictive, but we are deliberately forcing the conversation so we get to a conclusion, because it unblocks not just the eSig, but it unblocks a lot of other people in the WASI community as well, and it will really help everybody. So we're trying to do that. In the call, I was just doing a quick catch up. I saw a suggested method of working that we would define a tier 1 and a tier 2 list of things we try to achieve. There was a discussion as to whether or not having a 2-tier approach was a good idea or whether we should have a single tier. I don't know, was there a conclusion from that we should go for 1 tier or 2? I guess a no. There's no conclusion.
Chris, do you think the tiers we are talking about is about the spec wise or the implementation wise?
Because I saw a discussion where they were looking at an Excel sheet. So it was quite.
If so just from the implementation wise, I think many participants in the Watson community is trying to build the products with the Watson, and people mostly focus on what their product requires.
Mhm.
So, like we talk about some architecture we are working on. So I know that probably is not very popular, but is very important for us. So for our team, we will put that as a high priority. So
Okay.
um, um,
So I saw a discussion, there was two discussions going on. Well, there's one that where individual business needs from each of the participants dictate platforms to address. And there was also another discussion about target markets based on market penetration of an ISA. So
yeah,
there was discussion on risk 5 in that context too.
yeah.
Okay. So those were the two criteria to come up with a list. And then I saw Marcin suggesting that having a 2-tier list would just cause confusion in the community, and we should just have one list that we're targeting, where everything should work on it. And then there was some discussion as to whether that was a wise idea, or if we should have it could also work on these platforms, but it wasn't. They're not specifically supported, but they might work. So, but in listening to the conversation from last time, I didn't hear a conclusion to that question. Did you get one?
I can't remember any conclusion about that.
Okay, yeah. That's
I would
probably
agree that from watching the video, it kind of seemed like both were proposed, and it was, I guess it was clear to the tension I thought was getting expressed was like the fact that this list is getting really long.
yeah.
We've got x86 MIPS as well as ARM RISC-V. And I get it. We all have our products, so it's this interesting question of how do we balance those two? Because by definition, we're embedded. We're going to be tied to some ridiculous architecture that's really good at the one thing we're all here to do. But I don't know how we turn that into something that we can like hand to the broader community and say, target this, it'll solve most of our problems. And I think the answer is there's not that one thing. But
Mhm.
just the fact that we're talking about having 5 different ISAs that everything needs to back out to, um, you know, it seemed to be a bit much, but it is like what's represented within this group.
Yeah, I don't see an easy way to fix it. I think okay, I think for first cut, let's go for the 5 different ISAs and then just go for the next question is RTOS and and platform specifications for those ISAs, and going for the most aggressive of the platform specifications that are set as the target. And that's the way I think we could get like a first cut done, because otherwise we'll be spinning on this for a long time. I think it's just you got to just put your hands up and say there is no perfect solution, but we need something to move forward with. And if this covers most bases, it would do for now.
Yeah. So far for the embedded device, we already have a few companies already building products with WebAssembly, and I see the common requirement is that the one company want to maybe the application can be supported across all their own internal products, but there's no strong requirement. The apps works for their product can be working for other company products. Is that right? So yeah, that's a current situation.
So I think, well, I mean, this is where I guess the two-tier stuff comes in. If we did it this way around, where as a community, we target these ISAs and this profile, the hardware specification profile for those ISAs. And that's the thing that we would require everybody to support. So if a company's introducing a feature, or one of our contributors decides to introduce a feature, and they want it supported across the whole eSIG, then this lowest common denominator would need to have that support. Now, that does not mean that they are prohibited from adding it to other devices that are in their direct business line of interest. And I think that's really what we're coming up with, is if you want to add a feature and we want it supported across what we deem WASI embedded, then WASI embedded is everything must support this, and our lowest common denominator for the hardware platforms is that. But it doesn't mean that you can't build it on something more capable or better spec'd. But if you're going to add, I don't know, let's see, a system bus interface for talking to something, I'm making this up as we go along, but just a feature, and you want to add it, then we would want the equivalent on Extensa, RISC-V, 64 and 32. We want to see it implemented for all of the other architectures as well. And we say, right, all of these ISAs must support it, and we want this common base, right? There will be, peripherals and I2C or GPIO interfaces, which may or may not exist on the particular platforms that we're dealing with, and then they become kind of optional. But for those optional, based on whether or not you have those peripherals, it should at least exist for that hardware architecture, right? So it shouldn't be something that's not there. So that's the kind of, I think when we've got to think about the implication of specifying those minimums.
Yeah. So yeah, that's about the orchestration of the WebAssembly workload. Like in the industrial environment, like you probably want the workload can be running freely on all the field devices, but different devices have a different capability. So like some even don't have the GPL. So that might be some a upper layer kind of responsibility. Like I remember like the Silverline platform from Bosch. Maybe I'm not sure you already kind of manage the hardware capability and how to use that for the workload orchestration.
Yeah, we do that that's very much like that next level up, just like you said. We define like platform manifests, and based on those manifests, we assume that there's we assume that the WebAssembly interfaces for whatever hardware is exposed in those manifests, we assume that those interfaces do exist. But that is that's in close coordination with that layer up. So in the Silverline case, in the research case, it's that orchestration platform, but it could just as well be something on like the MES or SCADA side of the world. But it's that something in the system needs to keep track of the capabilities of each of these platforms because they are heterogeneous. But that's a problem that's independent from WebAssembly. Right now, on all those interfaces, we're rolling our own, and it's not pretty or portable beyond our internal system. So it's separating out that what gets forced on you because of heterogeneity, whether it's WebAssembly's problem or an orchestrator's problem.
Yeah.
Right. So there is like I think if you take that layering approach, then you need to have common set of bare minimums upon which you can have these optional extras depending on what the hardware does and can support. And then you can build everything on top of that. But the very bare minimum, ISA support, RAM footprint support, and RTOS or target operating system support, and then everything else is built up on top of that. You may have GPIO, you may have I2C, you may have a USB interface, you may have some graphics interface, and everything's built on top of that. I think that would be the way to go. Personally, feel free to disagree and tell me I'm wrong.
No, that's not, I mean, that's the way we've been building stuff is,
Right.
get the core well defined and then add from there.
And this is where, if we can, the goal is to get WASI working well on these devices, and that's where, having some host system description of capabilities would eventually become really important, right? And I think for the purposes of this discussion, we just assume that that's something that's going to be there. Once we get these minimum targets defined, we can then get on to the interesting bit of doing that. And I know that's something that I'm kind of excited to get to. But let's knock this out of the park and get this done, and then we're good to move forward.
And I just wondering, so like from Bosch and the Siemens point of view, do you see any need for the apps running on top of Siemens device can be running on Bosch devices? So do we need such level kind of for the BDD?
There are no plans, but there's nothing to say that it shouldn't happen, if that makes sense.
We've tried to convince business units it's a good idea. We're still working on them. But no secret there. But I think some of this is also like the difference between what is WASI and what is like the interface you would need for a PLC. I think, that's so domain specific that I hesitate to go down that discussion right now. But definitely looking at like PLC hardware, typical PLC hardware specs are something to pay attention to. I just feel like it's early to go down the how do we define a PLC runtime.
Yeah. I think it'd be much better to do to get that common bare minimum done first. That'd be great.
Got some of those notes taken down there.
I apologize. There's screaming kids in the background. Okay, so we've got the document, but should we take a quick look at it and go through it really quickly?
I think that makes sense. See where it's at.
Okay, I will try and share that. This is the one. You see a browser window?
Yes.
Right. So maybe we should have we discussed it, or I put in some suggestions for what the purpose of the scoping's for. It defines a common bare minimum that everything should support, but it doesn't constrain that you can't do more on it, if that makes sense. But if we had that in the meeting notes, and perhaps we should add that to the purpose of the document to make it clear. Must and should be supported. So we have this. And then arc should move to a must.
Mhm.
If
Okay, I'm not sure. It looks the Arc is a IP like block. Usually is a kind of adopted in some other platform like a CPU or chipset.
okay.
So I even don't know is can be provided like on board because
Mhm.
we just use it as a IP block.
Ah,
Yeah, Arc has a extensible instruction set, so that makes it kind of hard to fit this paradigm of fixed instruction sets.
what is
What
ARC?
exactly is ARC?
Let's now say
So, so it's what Arc gives you is a set of instructions and a compilable um, library. So you give the instruction and then you can construct a processor for that instruction set. Now you can extend the instructions for additional instructions that you like, and then it makes a processor which will handle those extra instructions that you added.
Oh,
So that's my understanding, and so there is a certain. That's what I okay. My knowledge is a few years old, but that was my understanding that there is a certain amount of extensibility to it that it's allowed.
sounds
Do
like
you have a
one.
link to this? So we can peek at it a little bit more. Is this like a, should we
By
think of this as a true processor or more like a DSP?
Yeah, it's more like a DSP.
Okay,
That's
cool.
the world I've seen it more. Yeah.
Because like it sounds like it sounds like some of the architecture papers I've seen in like ITSCA. Very exciting. But a little
is
terrifying to
by
be part of this list.
synopsis.
Okay,
Yeah.
sweet. All right, that does sound like them.
Okay.
So yeah, maybe we can remove it. I don't know. I guess the
Sounds
mostly
exciting.
some CPU kind of a company will use that.
Right. So then let's make a decision. Arc in or out?
I would vote out simply because it sounds like there's not one definition of what ARC instructions are. This feeds into I want to have my cake and eat it too. This feeds into the two-tier system is like even if the second tier is merely a laundry list of all the places that we have run WebAssembly, I think if companies are willing to say that they're putting WebAssembly on these platforms, I would love to make that information, as like I would love to share that information, just to show the breadth of places you can deploy WebAssembly. But I think having that as part of our base level of criteria is not useful if it is an extensible instruction set.
Yeah.
I
Yeah. So you can take, pick and choose from their instruction set. That's my understanding. So when I say extensible, that's it's saying is there's not a finite target as you mentioned. So.
well, okay. So there's another. I love the sound of ARC. And it reminds me of a whole bunch of research I only saw a little bit of when I was at Intel. I'm like, oh, I'd love to have a separate conversation about it. But one of the criteria I think we had for the hardware target is that we could point folks outside of our group who aren't delivering embedded solutions directly. We could point them to a commonly available development board, which would give them the instruction sets and the hardware profiles they would need so that they could go off and build and test software for our marketplace. So here I'm thinking about Luke, perhaps, and Fastly, who don't traditionally target an embedded system, but there's people in the WASM time community looking at building for an embedded platform. And if we're in WASI world, we want to say, hey, if you're building your WASI software, these are the boards that you should try and pick up, and these are the boards you should try to work on. So in that case, I would as much as I love the idea of ArcStat, it's really cool, I would vote to exclude it for now and revisit it in the future. Because I don't know if we've got a commonly available board we could target for that.
I agree with that suggestion.
Cool. All right, so that one. Extensor was interesting because I thought for sure that our colleagues in Midakura are using the ESP32. So I was
ESP is a very popular platform for embedded, so even we don't use it for now, just I feel it should not be excluded. And Midakura contributed a lot into the WebAssembly open source code.
and I know they participate in the European discussions usually. So were they on the call last time? No, I didn't see anybody.
I think Dominic at
But,
one point like called
but-
out that they were not there.
Right. Okay.
But we have a Dongsun from Sony. They are from the same kind of a big company.
Same family. He's on the call now, is he? No.
Dongsun, are you online?
Yes. Could you hear me?
Yes.
Yep.
Yes, we have some product based on Extensa to support warmer. Last year we have adapted the XIP solutions on the Extensa platform. So yeah, we'd like to have it in future and get good support.
I also
Yeah.
remember you mentioned the engineers from ESP32 are also working on WebAssembly, right?
Yes, we have some communication with Appressive, and they also try to support the warmer based on their platform of ESP IDF. Yeah. Which also based on Extensa chipset.
Any sense of how close they are to doing that? Or like if it'll be kind of how many of the Whammer features will be there? Is there anything that's going to need to be cut out, for instance? Like, I guess I'm thinking through, I feel like it should be on there, but at the same time, if it's not easy to run like Whammer on Extensa right now, can we include it in this list? Playing devil's advocate, I'd like to see it.
Yes, I think it's good to include Extensa support.
Okay.
Okay.
There are a lot of board, I think, on the market for with ESP32, and they are very popular in IoT space. So back to the IoT days, I think personally I also played with ESP board.
Yeah. I would be really keen to stick that in a must. And I think there's such a plethora of implementations and boards available for ESP32, and we've got some very large contributors who are using it in their products, that we would shift that into a must. What do you guys think?
I agree.
Agree with, yeah.
Do it. Great. And then we have MIPS, and in the call, I saw folks going, MIPS, Marcin says, hey, we have a very small proportion of stuff that uses MIPS. And then I think Dominic and Thomas were forward looking and saying, hey, what's the market for embedded MIPS devices going forward? Is this something we really need to worry about? So I'm happy to leave that as a should, but not compulsory, unless there's any objection to it.
Yeah, I think we should leave that on the should.
I mean, if I had my way, I would get rid of the should and just have the list of the 4 that we were going to target initially and just live with it for a while. But
I mean, we could also do that. Like, we could talk to Marcin and see how gung-ho he is about it, and or rather, like, how important this really is, or if it's just kind of covering all bases.
Yeah, I mean, this is for when we consider new WASI proposals, we want them to target the 4 architectures, the ARM, x86, RISC, and Extensa. And that would be a requirement. It doesn't mean that they can't target more, just that from an SIG point of view, when we're discussing what we need to do, the constraints and what we would want to do would be, it works in all of those ISAs, and that's it. So
Yeah, I can't.
I'm like, let's drop it if we have to, because I think it, from that point of view, I would cut it, but I'm happy to leave it on a should if there's a strong feeling. Let's follow up with Marcin. I think that's a good idea. Maybe we can do that in the next call. Thanks. Thanks, everybody. Okay, so then I'm happy enough with the MMU MPU support. Seems to make sense to me. The memory protection units optional, should be possible to run. MMU is not necessary. So there is a implication for mmap. And then RAM and storage requirements, and that's where I saw the table. And operating systems, and I saw a brief discussion last week. So from the brief discussion last week, I thought I heard Zephyr, FreeRTOS, Linux with RT patch, and then NutX was listed, because I know that's one that Sony and Midakura is using. As for the other operating systems, like WASI by default supports Linux, Windows, and Mac OS, I believe.
Should we drop those then?
Yeah, that's what I was thinking. Is it worthwhile just saying that's covered by WASI general? Do we have to do anything specific for it? Is there anything specific we're going to do for an RT patch that we wouldn't do for Linux normally? Task prioritization, maybe? Even then you could do that.
It depends, like, so much of that stuff, you probably don't want your WASM module to be able to schedule exactly how much CPU it wants. I feel like that is not an API I am going to give to untrusted code. But hey.
Yeah. I can hear that.
But you could also, you could define privileged WASM modules. But still.
Yeah. Maybe this would be a really good question if Luke's still there. I don't know if you're on the line. Good question for somebody from the more WASI side of things, from the core WASI side of things. Is there anything specific that you would imagine we would need to cover in the embedded side for, say, Linux and Windows that you wouldn't have covered already on the normal WASI side? Is there any constraints or requirements there?
No, well, yeah, I would guess the Linux cases, the hard case is already covered by these other operating systems, which is to say the lack of, an MMU, that sort of thing.
Yeah. Yeah.
Nothing comes to mind.
Which is why I was thinking if it was something we had to do, would we really want, I mean, is there anything extra special we have to do for Windows and Linux that, or anything we would have to share with the other members of the WASI community to help them target embedded systems with that?
I don't know anything about the embedded Windows world.
I think it came up
Personally.
in Xbox. Martin said they're running WAMA on the Xbox for Amazon Prime Video.
Cool.
Which is what?
Really Windows.
It's Windows on a AMD, isn't it? Xbox is AMD, isn't it?
Sounds right.
A Ryzen AMD thingy. Yeah. Okay, so it doesn't, I don't have to. So I guess we should think about why we're targeting these operating systems, and that would help define must and should. And it's, from my point of view, we want to target the operating systems that aren't already targeted by WASI, that have some unique constraints that desktop WASI, for the sake of a differentiating term, desktop WASI could address. So if desktop WASI is addressing Linux and Windows, is there anything more we need to do from a WASI point of view? Or are we good with the, let's focus on those operating systems that we need that don't come for free with desktop WASI, in which case it would be Zephyr, RTOS, and Nutex. Maybe Android.
I think focusing on those RTOSs makes sense. The only things I can think of that like you might end up propagating up into the Linux world, Linux, real-time Linux, would be if you're in a safety context running on Linux, certain rules about how much you can malloc or etc. may apply, but those should all be covered by the RTOS case. So I think we go down to just RTOSs.
Yeah.
Suppose it's a difference. Are you trying to come up with like the hard cases that if we can solve them, then other things get covered by the gamut? Or are we just saying what are all the places people might want to run it, which is, going to include all the points in the gamut?
Good point. Let's just do the hard bits that aren't going to be covered by other people. And let's go do that. And then by default, we should factor in those other points. So unless, I mean, probably make it's a conversation I'll have with Thomas when he gets back from vacation, because I'm pretty sure he'd be like, oh, I want Linux RT patch in there, but I'm like, yeah, we will use it, but won't we get it for free if we do all the other hard bits? And are we good enough with that?
Does embedded Linux run without an MMU?
I believe it could. Maybe. I don't know. Actually, I don't
And
know.
definitely, I mean, you need MMU is virtual memory, so
You need it.
don't think Linux is that happy without virtual memory in any.
Seems like it would radically change like the nature of the syscalls like him map. So I wasn't sure. But that would be interesting if it did support it, but I would be surprised if it did. So
Yes, can say I don't
Think so.
think there's a stable implementation of it at the very least. I'm just not even sure if that's like possible.
I think, but you bring up a good point, because I think
Oh,
that
you can compile for it. Sorry. Says the internet.
that's ChatGPT, must be true.
Hmm.
It's gone from asking Google to asking ChatGPT. But yeah, I think, it's interesting because I know in the back of everybody's head is a bunch of features that we want to do. And some of those features are things like mmap stuff, which would be really advantageous from a sharing memory between modules and sharing memory between the host and the VM. That would be kind of cool. Wouldn't it be wonderful if we could do all of that? And that kind of means that we've got this two-tier platform going on where we've got the RTOSs without the MMU, and then if you had the MMU, you could do all this cool stuff. But from a pure RTOS point of view, if we could address that with and without an MMU, without thinking directly about Linux, I would put Linux in a should and put NUTX in a must. But that's me, because I'm trying to think really hard about the operating systems that nobody else is going to look at, that we need as a community. I'm like, Linux, there are other people that get running WebAssembly and WASI on Linux. The MMU stuff will probably come on that anyway. The operating systems that the embedded community need, more likely to be Zephyr, FreeRTOS, Linux, NUTX, and Windows, Android might be a should. Any objections? Tell me I'm wrong. I'm up for somebody telling me I'm wrong. It's all good. So what if we propose that we would switch Linux for NUTX and then just say, look, we're going to target the operating systems that nobody else is going to look at, that we need as a community. And those would be the things that we would focus on. So if you're going to do a component that exposes some feature or provides some functionality, or you're defining an API that does it, it must work in these real-time operating systems. And then if it works for those, it should be relatively easy, but not compulsory to implement it for everything else. We good with that?
Works for me.
We've got one person supporting. We have silence on the rest of the call. Anybody else got a view on it? I guess the one organization person that might have the biggest view on this is the one supporting the widest possible list of in production operating systems, and that's probably Marcin, I would say. But I'm also really keen to the matrix of possible combinations is getting bigger. So let's shift it to NUTX, drop Linux, and then have a discussion with Marcin if that's okay. That's my view. Just to try and drive the conversation forward and see what everybody else thinks. If you're good with that, then I'm going to propose we make that change. And I can see an action item for me to edit this document and update it. Okay.
I think if we start to make changes, then at least we can have that discussion. We've got a nice meaty discussion for 2 weeks from now to just dive into.
Yeah. And we can probably start an online discussion on the Git repo as well and get that going. Based on the meeting notes, we can copy and paste it into discussion points that we're raising and kick it off. That'd be a way to get it going in the meantime. So then this is the Excel sheet, wasn't it? Like for each of these platforms, what RAM storage and board should you buy so that you can develop for us? for our community or in our community. And that was the Excel sheet, which I haven't got open. And that comes down to RAM and storage requirements, which is something that we are 9 minutes away from the end of the discussion, which we need to cover.
We settled on this a couple of weeks ago.
Did we?
I had notes that it was there were numbers for this.
Awesome.
Let me find them. I guess I didn't get propagated into that. That makes sense. So what would that have 2 weeks? What? No, 4 weeks ago. Oh boy.
I think I was on vacation for that too. So
I've got notes here that we concluded about 512 kilobyte, and we can also like discuss this now, but that based on the fact that Siemens said they were working with about 300 kilobytes of RAM, I think Shin said that Whammer was working with like at a minimum of like 26 kilobytes, just the interpreter gets super small. Someone else said they were the smallest board they were working with targeted 512 kilobytes. So the conclusion there was smallest we were going to go was 512 kilobytes of RAM.
okay, perfect.
I think I didn't say 26 kilobytes. I doubt that Walmart can't support that small device.
Maybe someone
I don't,
else must have thrown that out. Sorry.
yeah, I'm not sure. In my impression, we at least
maybe?
80 kilobytes in Pierce test. 80
Cool.
kilobytes, probably.
Advise that. Pretty small though.
I am of the view if we stick it in the document so we can rip it apart and be upset over it later. But I'd rather help drive the discussion forward. So
Oh, and then the storage requirement was a megabyte.
yeah. Okay. So it was 5. We're going to stick with 512 and a megabyte. Having flashbacks to my school years playing on a Commodore Amiga with 0.5 megabyte of RAM, and it sounds like one of those. Perfect. So I can stick that in the document too. And then I think we are down to just picking out boards for each of the ISAs, which are things that we should target when we are building stuff, and we should test that these work on it.
I had a question about the MPU bit,
Sure.
if we could. I was wondering, it says, MPU support is optional, but I'd be interested to know, for example, let's say there was a technique, an optimization technique that worked if you had an MPU, but didn't apply if you didn't have an MPU. How valuable would it be to like develop that? Like, how much do we think MPUs like 50-50, 25, like, how weighty is MPU only sorts of optimizations?
It's a good question. I can give you my personal view on it. And what you're seeing is two things: legacy hardware and cheap hardware that doesn't have any memory protection at all, any memory management protection at all. And you get that there's an inflection point where you just go, hey, for this particular platform, it's just worth it. Just pay the extra couple of pennies and get it. But that's this inflection point. And I think what we're getting in this discussion in the document and the previous discussions is folks going, ooh, how much of my existing embedded space could afford those few pennies? And am I going to lock WebAssembly and WASI out if I don't have it? From a feature development point of view, I personally think definitely do the performance gain on for the hardware available MPUs or MMUs. Really important to do that. It just adds extra weight and pressure on folks to put the couple of pennies in because you're going to get it back out later on. And from a forward-looking architecture point of view, you'd argue that Moore's law is still very much in effect for the embedded side, and those costs are coming down, and we're gradually moving to more capable silicon. So therefore, definitely target that. And this is just a weight we're paying as we're moving forward. But that's my personal view.
Right. Well, yeah, that's helpful. So an interesting question that might rise up is if we have like a design where like, well, if you have an NPU, this is an O1 operation, and but if you don't, there's no end copy that happens.
Yeah,
We can say, well, will we be satisfied by such an answer?
you're gonna have to be, I think. Because there comes a point where, well, there's a reason why we have NPUs and MMUs, right? It's exactly to solve this problem, and it comes up in software resilience and in the security contexts and permission domains, and half of what we're trying to do with WebAssembly supplies some form of that. On the lower end devices without that extra hardware, yeah, you can have some protection. It's going to run a bit slower, but hey, if you had your MMU, NPU, you would have a better implementation. I think that's an okay trade-off personally. But I would throw it out to other folks in the embedded space who have products in production right now. So Don Shen or anybody else. Emily, you on it?
So much of the stuff we're targeting is like it. I mean, heck, it's running an adapted form of Linux. So like, I really can't comment here. I think some of it is like it's either running an adapted form of Linux or it's like a beefy ECU that definitely has an NPU on there. I just think at this point, I have trouble worrying about the non-NPU ICs at this point.
Mm-hmm.
Is there any chance we can capture this sort of feedback, which is very useful and kind of a nice guidance actually for some of these design problems in the document, perhaps?
Yeah, I've got that. I'm writing that out as a to-do right now, is like clarify what we mean by optional. It's like, it should be possible. It can be glacial. Hopefully it's not glacially slow with an NPU, without an NPU, but like, you know what you're getting into. You being the person who chose the non-NPU hardware.
Some product owner somewhere's decided this was a good idea to save a couple of pennies and everybody else in the team has to suffer. You know that's what's happening. And there will be some software engineers going extra gray in the corner of the room. But not that I'm speaking from experience or anything, or that I have gray hair. These things never happened. Don Chen, I think you were unmuted for a second, and just if you had any views on it.
Yes, I have one question for the MMU support. As I know, I think if we should use a large-scale applications like large linear memory, or if we try to support the AOT, and AOT has large size, for example, more than 1 megabyte. So in this case, I think the MMU support that to say use the virtual memory is very important. So I'm not sure why we should the MMU support is not necessary. As I know, the small application might not use it, but if we try to support a big application, it might be very useful. So I feel confused why it's not necessary.
That's good feedback. And by big, we mean megabyte or bigger.
Yeah.
That's have a discussion. Let's kick off some online discussions on the Git repo for MMU support and propose that we change it to compulsory. It's not optional. And there needs to be an MPU or an MMU. One
I
of the
was guessing that the intention of this was to say we're not going to have designs which require an MMU, not that we're not going to support them. It's almost like MMU is an embarrassment of riches. So it's so when you have it, you're good, but what we're not going to do is consider solutions that require it. That's what I was extrapolating.
right, but not prohibit designs that need it, I think is the key.
Yeah, I mean, it's so flexible, it's hard to imagine how we'd prohibit it.
Because I'm thinking about the mmap, because we called it out directly here, the mmap support. And if it's an MMU, that would be pretty cool, but not have that in all platforms, which I think is okay. So
There's just like, there are real-time situations where you don't want an MMU. It adds uncertainty in your timing.
true.
So there are platforms out there that will hit all of the other metrics, but they intentionally don't have an MMU because of that. And I think those are still valuable to hit.
See, this is good. We need to capture this and stick it in the document as the justification, I think. That would be really good. We are 3 minutes over, I think. But this has been good. I'm going to stop sharing because I think we've got a very large to-do list, which I might have inadvertently volunteered for most of it. Never mind. I'm going to have to be quiet on the next call so I don't have anything to do. Cool. Let's try to get the conversation going online, update the document, and then start some issue discussions on that repository so we can drive this forward, because I think it's all of our interest just to close this out and move on with something much more interesting. Luke, thank you so much for the input, actually asking those questions and helping to get us to put the explanation into the document for the wider community is really important. Also helps the readability. And great input from everybody else. So thank you so much, folks.
Thank you all.
Before we close out, I know we're over time, but is there any questions on logistics, meeting timings, stuff like that? I have a to-do to fix the calendar invites, and it's something I'm going to do this week. So I've got calendar invites and document updates and GitHub issues to do. Any other questions on that, or are we all good? Silence. Tumbleweeds. Go.
All good.
All good.
All good. Awesome. All right. Well, folks, it's coming up to 8 p.m. here, 9 p.m. on the East Coast. And I know what 9 a.m. in Beijing, I think. So have a fantastic evening, a fantastic Tuesday to our colleagues in Asia. And I will be seeing you. There'll be no updates for the rest of Tuesday for Asia, but I'll be working on it my Tuesday. So you should see it Wednesday. You start to see a few things popping up. In the meantime, have a fantastic evening, fantastic Tuesday, and I will talk to you again in 2 weeks with our US colleagues and our European colleagues, where we will try to drive this forward and get this document out of the way.
Okay.
Sounds good.
Awesome, folks.
See you all around.
See you. Bye-bye.